We start by creating a bacterium. One of the fastest and simplest ways is to create a capsule, run it through a remesh to generate a cleaner mesh, and then use the brush tool in polygon modeling mode to sculpt the desired form. To save time, I'll immediately show you a few bacteria I have already prepared. Feel free to use any references from the internet and model them quickly. The main thing is to keep the polygon count low, because later we will need a very large number of objects. Next, we add our bacteria to a cloner, set the count, and apply some random factors to introduce variation. Before applying dynamics, we need to create a box container using a cube. This container will catch all the bacteria as they fall and prevent them from escaping through the sides. Then we apply rigid body to the bacteria and add a collider to the cube. At first, you may notice some bacteria passing through the walls. This can be fixed by increasing the number of collision passes in the scene in simulation settings, or by adjusting the collision shape. After that, everything works correctly. Now we convert our cloners into objects. These will later serve as the floor or background layer where bacteria are visible but not simulated, essentially static geometry. To enrich the scene, I add a few more objects. For example, I used a coral model I downloaded and applied a collider tag to it as well. At this point, our main scene is ready. In the rigid body tag, we press Set Initial State, so that the simulation doesn't have to recalculate from the beginning each time. Now it's time to create a field force, which will drive the bacterial movement. We start by adding a volume builder with a cube roughly matching the area of our bacteria. Inside it, we add a random field with parameters like Object Below and Cross Mode. Here you can play with different settings, scale, and noise types. In the volume builder, we then add two modifiers, vector normalize and vector scale. The vector scale is driven by a shader field, which serves as a mask that controls where the field force is applied and where it is not. We increase the scale, adjust contrast, and add a bit of animation. This way, some areas will have bacteria in motion, while others remain static, adding variety and a more natural feel. Finally, we create a field force object and assign our volume builder to it, adjusting the force type and strength. Now, we can already see our animation working. You can further tweak the random field, noise field, and shader field parameters to achieve the desired look. If you notice some bacteria not moving, simply move the field force or the volume builder slightly up or down. This usually fixes it. With vector scale, you can also control the speed of bacterial movement. At the end, we enable our static floor bacteria so that they fill the transparent gaps beneath the main simulated ones. And that's it! The scene is complete, and the animation is ready.